This series of videos will focus on a general introduction of Java's program structure and Java concepts, as well as some examples of using a development environment, and I'll be using Eclipse. So we're going to start out with just some very basics about Java program structure. Java is divided into classes, so the underlying fundamental division of Java code is into classes. Now, most classes are contained in their own file that has a .java extension, and the name of the class and the name of the file are the same, and that's case sensitive. So if you have a Java class called student, that file is going to be stored, so that class is going to be stored in the file student.java. Within that file, you'll have a class header, and that's what defines the class. And then you'll have a class body that'll be surrounded by curly brackets. So here's an example of a simple class. This would go inside a file simpleclass.java. And this particular class has two methods in it. Here are the brackets that surround the class body. So this is our class header, public class, simple class. And these are the brackets that surround the class body. So classes are organized into packages. The package structure in Java is actually one level above the class. We have packages, and then within those packages we have classes. And within those classes we have methods, and those methods we have program statements. We're not going to worry too much about packages now. We'll talk about packages later on, but for now we're just going to focus more on classes and how those are used to organize Java code. So our classes contain methods. Just like we had a class header that defined the class, we also have method headers that define the method. The method header contains a couple specific pieces of information, contains the visibility, the return type, the name of the method, and a list of formal parameters that are associated with the method. The formal parameters are the inputs to the method. Now, two of those things, the name and the formal parameters, are known as the method signature. So the method header is all four pieces of information. The method signature is just these two pieces of information, the name and the formal parameters. After you have the method header, you have the method body, and that's surrounded by the curly brackets. Now, within those curly brackets of that method are program statements. So a program statement is just essentially a single line of code that ends with a semicolon. So going back to our simple class example, again, this was our class header, and these were our curly brackets that surround the class body. Everything in between these curly brackets are inside this class, so they're a part of this class. And then here we have a method. This is our method header with those four pieces of information, the visibility, the return type, the name, and then the formal parameter list. If there are no parameters or no inputs to a method, the parameter list will just be empty, but you're always going to have those parentheses. If there's inputs, they'll go inside those parentheses, and if not, they'll just be empty. And then we have our method brackets. Oops, this should actually be here. Our method brackets that surround the method body. For now, just ignore this part of the method header. We'll talk at a later date about what static means. So again, we have the different components of the method header. These two pieces here, the name and the parameter list. In this case, that parameter list is just empty. There are no parameters on the list. These again make up the method signature. Inside of this class has two methods, this one and this one. And inside of those methods, we have some program statement. So here is a program statement, again, ends in a semicolon. Here's a program statement, ends in a semicolon, and this method has one program statement. So that's the basic breakdown of your Java class. Again, you have the class header, the curly brackets that surround the class body, and then within the class you have methods and the curly brackets that surround the method body. Now there's one special method in Java, and it's called main. This is a special method because this is what's launched when you run your program. The main method has this exact header, public static void main, and it takes one parameter. That parameter is a string array, which we indicate by capital S string followed by square brackets, and then we give that array a name. It's typically called args. So this exact header should be used in your main method. Now, as we learn a little bit more about Java, we'll learn what each one of these pieces mean, but for now, just use this exact method header anytime you write a main method. And again, the main method is what is launched when you run your program. So let's talk a little bit about the syntax rules of Java. Syntax rules are the rules related to the Java language. So Java is case sensitive. That means whether you put something in uppercase or lowercase matters. So you need to be really careful about that. Java ignores white space. So you can have lots of tabs and lines and blank lines separating your code, Java doesn't care. It's going to ignore all of that. But human readers of your code do care. So it's really important when other people are going to be reading your code, which they almost always are, to have things formatted well. And we'll take a look at how you can use your development environment like Eclipse to help you with that. But you want to have good white space for your human readers, but just remember that Java doesn't care about that. So it's going to ignore whether you have a blank line or an indentation. Java doesn't care about that. That's not part of the Java syntax. There are two main ways that Java provides to comment code. One is with the 2 backslashes. This can be used for kind of one-line comments, so short, brief comments that will go along your code. If you have longer comments that are going to span multiple lines, you can use the \* and then write your comment and then end the comment with the *\. So everything between these two indicators, comment indicators, will be commented out. It is really important to comment your code. Very few people enjoy doing this, but it's a really critical step, and I'm going to strongly encourage, and in fact require you, to get into the habit of just commenting while you write your code. So this is a much better approach as opposed to writing all of your code and then going back later and writing the comments. That's not a great way to go about it. It's best to just write comments as you go along writing your code. It'll make it easier for you to go back and make modifications. It'll make it easier for other people to understand what's going on in your code, and it'll make it easier for other people to eventually modify or maintain that code. So we talked a little bit about how Java was case sensitive, so it matters whether things are uppercase or lowercase, and there are certain conventions that Java follows. Now, these are not part of the syntax. That means if you don't follow these conventions, it's not going to give you an error. Your program's still going to run, compile, and all of that. But these are conventions that people within the programming community follow. I'm a fair, strict person about conventions, so I'm going to be a stickler about this in your classes when you write your classes for submission. So get used to these conventions early and use them. When you name classes, classes use capital camel case. That means they start with a capital letter, and if there is more than one word in the name of the class, the second word would also be capitalized. Classes are usually single nouns. So student, string, employee, for example. Methods, on the other hand, use lower camel case. That means they start with a lowercase letter, but if there's more than one word in the name of the method, the second word will be capitalized. So calculate total, for example, the C is lowercase, but the total T is uppercase. Methods are usually descriptive. They often contain a verb like get ID, print, display, calculate. Methods usually describe actions that we take, and so they usually have a descriptive verb as part of their name. I will use these conventions in my examples, and I will give you feedback if you do not follow these conventions, because again, although it's not an error, it is really important to just get into the habit of following these conventions in your code. Okay, let's talk a little bit about some of the key principles in the Java language. Well, Java is an object-oriented programming language, and that is the heart of Java. So an object-oriented approach really relates to breaking a problem down into pieces, and those pieces are basically classes and objects. So the object is the fundamental entity in a Java program. Everything comes down to classes and objects in Java. Objects are used to represent real-world entities. So if you were writing a system that might process data about employees, you might have an employee object and a company object. And those objects would be described by a class, the employee class and the company class. It all comes down to objects and classes. That's what an object-oriented approach or an object-oriented language is all about. So in Java, all of our variables are either going to be objects or they're going to be primitives. And we'll talk about the distinction between those two things in a later series of videos. But this idea about object-oriented program, the idea about breaking things down into meaningful units that often represent real-world things like students, employees, companies, strings, that's at the heart of Java. So the idea of breaking it down into these real-world components. Those components are known as objects. So an object has two things. It has a state. The state is the descriptive characteristics of the object. So these are things that describe it. Let's take, for example, a bank account. So bank account is a real-world object. If we were writing a system to describe banking, we might have a class called bank account, and we might create several different objects of type bank account. Those objects will all have state. A state, again, is descriptive characteristic. So a descriptive characteristic of a bank account might be the account number. It might be the balance. It might be the name of the account, etc. It's all things that describe that object. So you can think about objects usually as nouns, right? They're things. And the state of that thing is the characteristics that describe it. And then that object also has behaviors. So these are things that the object can do or actions that can be taken on the object. So for a bank account object, you can think about actions like making a deposit, making a withdrawal, checking the balance, adding interest. These are all actions related to that noun. So again, the object is the thing, it's the noun, and the behaviors are actions that can be taken on that object or actions that that object can take. So in Java, our objects are defined by a class. So a bank account is going to be a class. The class lays out the blueprint of the object. So it defines what that object's going to look like. That means it defines the state, the characteristics, and it defines the behaviors, which are the actions. Once you have that blueprint laid out, then you can create individual objects. So once we've defined what a bank account looks like, then we can say, okay, let me create an object that represents Jess's savings account, and let me create another object that represents Jim's checking account, etc. So you write one blueprint, one design of what an object looks like, that's the class, and then you create multiple objects from that design. That class defines methods to represent the behaviors, and uses what's called instance data variables to define the state or the characteristics. Okay, so again, you have this blueprint, that's your class. The class defines methods and variables to describe those objects. And once you've got that whole design blueprint written, then you can create multiple objects of the class. So the class is really the concept, and an object is an embodiment of that concept. Another way to think about it is that a class is like a cookie cutter. It kind of defines what something's going to look like. But then when you take that cookie cutter and you make cookies, each one of those individual cookies is an object. But they're all cut from the same cookie cutter. Object-oriented programming and this idea of objects and classes is, again, the heart of Java. That's the main Java idea. And we're going to talk about it in almost every video and every lecture. We're going to come back to this idea of objects and classes. So it doesn't have to really totally make sense yet, but just start thinking about this idea of objects and classes, and we'll continue to formalize it as we go along. There's a couple other key ideas that are part of what make Java Java. One is the idea of encapsulation. So we'll talk more about this later on. But the idea about encapsulation is that we have these objects, and each object manages its own information. So a bank account has state, like the balance and the name on the account and the ID of the account. That object manages all that information on its own, and it decides how that information is given to someone else outside of itself and how that information can be changed. So the bank account class defines how other objects access its information. We'll talk much more about that when we talk about class design. Inheritance is another big key idea in Java, and this relates to the idea that classes are all related to each other through a hierarchy. So it's not that you have all these individual classes all out in the Java universe, but they're actually all related through a structure. And the inheritance structure is an ISA structure. So an easy example to think about is if you have that class called bank account, you might have another class called savings account, and a savings account is a bank account. It's just a more specific kind. And so in Java, we represent that relationship of ISA, kind of is a more specific type, through inheritance. Polymorphism is related to inheritance, and it's a big idea, but it's hard to describe until we get more into the details about inheritance, so I'm just going to put a pause on that for now. All of these ideas are things that we'll use now. We're going to be using these ideas in the classes we write, but we'll kind of formalize the definitions of what they mean later on. And this will happen a lot in this course. I'll say things like, for now, just use this part of the code, and I promise we'll explain it later. But sometimes it's important for us to be able to use things early on to get our programs running, and then we'll go through the details of why they work later on. Okay, that's the end of this first part of the video, and in the next part, we will pick up talking about the programming process.